So in the competitive exams, they are asking the questions based on application of this particular expansion of solids. See, alpha is equal to, I am writing delta L by L into delta T here. See, the next one, alpha L into delta T is equal to delta L. This can be equal to, what is that? L2 minus L1 is equal to alpha L into delta T. So L2 is equal to, what is that? L1 plus alpha L into delta T. So I am taking this initial length, so that's what I am taking this L1. So L2 is equal to L1 into 1 plus alpha into delta T. So this is the initial length, this is the coefficient of linear expansion. See, this is the temperature difference. See, if you are applying the same formula for the time period of the simple pendulum, so consider this is the simple pendulum here. Let this is the length. Here we wanted to find out the time period. We know the formula T is equal, what is it? 2 pi under root of L by G here. So this is the length of the pendulum, this is the acceleration due to gravity. As the temperature increases at that particular place, provided G is a constant, because place is not varying, only what varying is delta T changes, temperature changes. Initial time period T naught, I am considering this 2 pi under root of L naught by G here. Whereas as the temperature increases, time period T1 is equal to 2 pi under root of L1 by G here. If you are comparing these two results, T1 is equal to 2 pi under root of L1. So L1, what happens is that as the temperature is increased by amount of delta T, at which L0 is present. So the relation between L1 and L0, by using this equation, how can we write down L1 is equal to L0 into 1 plus alpha delta T here. See, if I are writing this L0 into 1 plus alpha delta T by G. Simply what we are using this, in the place of L1, I am applying this equation. This is the initial length. So here we are considering this is L0 is our initial length. Again, alpha is the coefficient of linear expansion. Here our assumption is delta T is temperature increases. That's what we are writing, L0 into 1 plus alpha into delta T by G. See, T1 is equal to 2 pi under root of L0 by G here, 1 plus alpha delta T, provided alpha is very less. We know that coefficient of linear expansion is very less. So we can write down L0 by G into 1 plus 1 by 2 alpha delta T here. This is about T1. So T1 is equal to, if I am writing this 2 pi under root of L0 by G here, this will be, what should be this? T0 into 1 plus alpha delta T. So T1 by T0 is equal to T0 into 1 by 2 alpha delta T here. See here, if you are taking this T1 by T0 is equal to T0 into 1 plus 2 alpha T here. See, if you observe this, otherwise we can write down T1 minus T0 is equal to T0 into 1 plus alpha delta T here. T1 minus T0 by T0 is equal to 1 plus alpha delta T. So this is change in time period by initial time period, how much it differs, 1 by 2 alpha delta T. This is change in time period by T0 is equal to 1 by 2 alpha, this is temperature. So this will be time period, this will be, what is it, change in temperature. This is the application of how the time period of simple pendulum. This is one of the most important application that we are expecting in the examinations. Next, another applications. that is called thermal stress. See, what do you mean by thermal stress? Here, suppose if you are taking that one rod that has to be clamped between the two fixed ends. Just now we discussed, as the temperature increases, definitely initial length L here is length L prime has to be increased than L according to that expansion of the solids. In our household things, we have so many stands, so many frames, they are fixed at both the ends, but as the temperature increases, but they will not move from here to here, or they not move from here to here. So in the summer they should definitely they should expand, in the winter they should compress, but in our normal practice we don't observe this. So what force which stops this particular expansion in the summer, which stops compression in the winter, that we are going to discuss under the topic of thermal stress. See here, if you observe this, as the initial temperature is T1 and initial length is L1, as the temperature increases, let T2 is length increases by length 2. According to our expansion of the solids, alpha is equal what we derived delta L by L into delta T. So this is the change in length, this is the initial length, this is the temperature difference. So T1 and T2, so T2 minus T1, what we are taking this is the temperature difference. And length difference, what is that? L2 minus L1 is equal delta L. See, according to this one, delta L by L is equal to alpha into delta T. This is because of thermal stress. So in elasticity we are going to discuss what do you mean by stress here. Change in parameter by original parameter. Here I am defining in the terms of length. That's what I am taking, change in length by original length. That's what we are taking, the thermal stress. But according to that definition of this Young's modulus, how we are defining Young's modulus? Y is equal F by A, stress by strain. So delta L by L is equal to F by AY. So here this delta L by L because of variation of temperature, whereas this delta L it's because of elastic property of this material. By resultantly this delta L by L and this delta L, what happens there? There is rod or clamp, what happens there? Summer initial length L1, it exists same length, in winter also it exists the same length. So definitely this resultant of this thermal as well as this elastic, that should give what happens at zero effect. So this is about thermal stress, this is about tensile stress. So I am writing this delta L by L is a thermal stress plus delta L by L is a tensile. We are taking compressive also. We will see that two cases. This can be equal to alpha delta T plus F by AY. So this has to be what happens at 0. See here, if you observe this, as the temperature increases, this delta T term increases. In summer, definitely what happens that this delta L by L increases. So L1 becomes L2, so your L2 is greater than what happens at L1. So definitely as the frame it moves from here to here, it expands from this to place, same equal amount of force has to stop this expansion. That stopping of this particular force, this one what is in the terms of is coming to this side, we are calling as compressive. So if you are taking L alpha delta T is equal minus F by AY. Suppose delta T is a positive. In summer we are observing the temperature increases, this metal rod increases. As metal rod increases, what happens that there should be a same amount of stress has to be developed in the opposite sense, because in normal practice we don't have any change in the length in the summer or winter. See, delta is positive, summer we are expecting delta is a positive, so definitely what happens is same amount of stress. So here this F by Ay, it governs what happens, that compressive stress. In the winter, delta T is negative. This delta T is negative. So F by Ay, what happens that delta T is negative, obviously this L1, what happens that coming to the compared with the L1, L2 is decreases, same amount of stress has to be expanded in such a way that F by A, that gives tensile stress. See, this delta T is a positive, it becomes a negative. This negative sign will take care of this compressive stress. Suppose delta T is the positive, so here this will be the, what happens that it should be the negative, this tensile stress will take care of this sign. See here, if you observe this, so these are the applications of thermal stress and time period of simple pendulum. Next, coming to that expansion of liquids. As solids can be heated directly with this particular heater and all, but whereas liquids, they cannot be heated directly, they should pour in some vessel. This is the vessel here, let the volume be here. If I are heating that, then what happens that these liquids, they can be heated by means of this vessel. First, this vessel can be heated, by means of vessel the liquid can be heated. So as the liquid can be expanded from the point from A to B here, definitely we have to consider the expansion of this vessel. If we are considering this a long neck like this, I am drawing this like this. Initially position is A here. As heat, if you are supplying the heat there, initially this vessel is getting expanded, so this liquid rises. Initially what happens is it falls down, it comes to the point B here. Next, after getting heated, this liquid goes to the point C here. See here, if you observe, initially the liquid level is at A. As the heated, because of the expansion of the vessel, it comes down, it falls down to point B here. See, this AB, it gives expansion, is due to expansion of vessel, whereas BC, it is expansion of liquid. But we observe only the expansion of the liquid from A to C only, we won't observe this A to B here. This AZ is also expansion of the liquid. But the thing is, both the cases BC and AC, this is we are observing from A to C, actually it expanded from B to C. So we are calling as BC is the real expansion, AC we are observing, this is called apparent expansion. If you observe that this is a straight line, provided what we are taking this BC is equal to AB plus AC here. If I am taking this BC by some A into area of the cross section is in here, delta T here, this can be area, one more thing here, AB by A into delta T here, this is AC by A into delta T here. See, if you are taking this area of the cross section is A and length L here, so also L here, it's also L here, this is the area of this one. So then finally what we are getting this is about that change in length by this volume BC, otherwise we take this BC by V into delta T by AB by V into delta T here plus AC by V into delta T. So that we define what is that gamma, the real will be equal to gamma apparent plus gamma glass.